Welcome to another video in game theory. So in this video, we're going to talk about dominant strategy. Now, dominant strategy is the idea that one player can always pick a strategy that is going to result in the best payoff. No matter what the other player chooses, we're always going to choose that one strategy, and we're going to refer to that strategy as the dominant strategy. This is like if you're playing chess and you always want to move the king, or I don't really play chess, but let's just pretend I do. And that's always going to result in the best strategy. So you can all complain about that later if that's a bad move. Now, here is an example of a game matrix. So let's just talk about the game matrix a little bit just to review and freshen up. So what we have here is we have two players. We have Bob and Alice. So let's start with Bob. And Bob is player one. So we'll just do P1, and he has two strategies. He can either run or he can stop. Notice player one has the rows and player two will have the columns. So player one, okay, Bob, if he chooses to run, his payoffs will either be 1 if Alice chooses to run, or -1 if Alice chooses to stop, and 2 if Alice chooses to run, and 2 if Alice chooses to stop. So now these are Bob's payoffs, right? The first number is always player one's payoffs. Now we're trying to figure out the dominant strategy. So should Bob always choose to run, or should he always choose to stop? That's the question that we are asking. So how do we decide? Well, if we look at this, okay, let's look and check out, let's keep Alice's strategy the same each time. So let's look and see what happens if Alice chooses to run. What should Bob choose? Okay, so if Alice chooses to run, what should Bob choose? Should he choose to run, or should he choose to stop? Now remember, the higher the number, the better the payoff. So we have 1 and 2. Well, it appears that we should choose to stop. Okay, so in this first instance, if Alice chooses to run, we should choose to stop. Bob's best interest is to stop. Now let's go over to the stop column. Okay, here we are. What if Alice chooses to stop? What should Bob choose? Well, we have -1 and we have 2. What's the better payoff? Well, positive is always better than negative, right? So 2 is a higher, so Bob should choose to stop. Now in either case, whatever Alice chooses, what should Bob choose? Well, Bob should choose to stop. So what that means is stop is going to be Bob's dominant strategy. Dominant strategy. So the cool thing about this is if you ever figure out what your dominant strategy should be, you can always go with that. And it's always going to be your best choice. You don't even have to think about the moves or try to analyze what the other player is going to do, right? No need for poker glasses here, sunglasses. Now, let's look at another example, but this time we want to figure out Alice's dominant strategy. So remember, in this case, Alice is going to be player 2, since she's on top here. And again, she has two choices. She could either run or stop. Remember, Alice, since she's player 2, she's going to have columns. Now, since she's also player 2, that means the second number, player 2, second number, woohoo, connections there, okay, means that all the second numbers are going to be her payoffs. So we can basically ignore Bob's payoffs, which are the first numbers right now. Okay, so we're trying to decide, should Alice run or should she stop? Now we're going to do the same thing we did before, but this time we're going to keep Bob's choices the same. So if Bob chooses to run, what is Alice's best decision? So if Bob chooses to run, should she choose to also run or stop? Well, 1 and -3, I'm going to choose a positive number, right? Always a better payoff. So Alice, the best choice would be to run. Okay, now let's skip over to if Bob chooses to stop, what should we choose? Should we choose to run or stop? Well, -1 or 3. I'm going to go ahead with 3 because that seems like a better option for me. Now, there's a problem. Okay, if we look at this, if Bob chooses to run, Alice should also choose to run, right? That's what we said. But if Bob chooses to stop, Alice should choose to stop. So depending on what Bob does, Alice should do something different. So since Alice doesn't have one strategy that's always going to work, we would say Alice does not have a dominant strategy. So no dominant strategy. So that's what we're going to go with here. So let's finish that up. Strategy. Okay. Now we have one more example we want to get through. So the last example is what value needs to be placed in A for player 1 to have a dominant strategy. So now we have a very general game matrix, okay? And we're missing a number that we need to plug in for this little a, lowercase a. So let's talk about this. So we have our player 1 over here. We have our player 2. Notice that for player 1, it has either the choice, the strategy of A or the strategy of B. So this was kind of like the run or walk option, or run or stay. Yep, that's what it was, run or stay. And player 2 has the choices of C or D as their strategy. So just keep in mind these just represent different strategies. Don't get hung up on the fact that they're variables. So run, walk, stay, cooperate, whatever it is your strategy is. Okay, now we want to figure out what player 1's dominant strategy is. So player 1, let's go ahead and just circle player 1's payoff so we can just concentrate on those and ignore player 2's because they don't matter when we're trying to find player 1's dominant strategy. Okay, now remember, player 1's dominant strategy depends on what player 2 chooses. So if player 2 chooses to go with strategy C, okay, we want to look at the payoffs for player 1. So we have 3 and we have A. So we don't know which one should be bigger right now because we don't know the dominant strategy of player 1. So let's put that on hold and come back to if player 2 chooses C. Let's instead go to player 2's choice of D. Okay. Now, if we look here, you have 0 and 1. Which one would be dominant? Which one would be a dominant strategy? Well, 1 would be the dominant strategy because it's higher, right? So that one means player 1 should choose option B or strategy B. So if we come back to this first column, okay, where player 2 is choosing option C, you have 3 and you have A. Now, we already said that B should be the dominant strategy, which means B should be a larger number. So if A has to be a larger number than 3, what can A be? Well, A can be anything bigger than 3. So we could put in A could be 4, A could be 5, A could be 6, keep going, right? Any number that's larger than 3 that we put in there would mean that B would be a dominant strategy because it's larger than 3 or that other option. So if you're trying to figure out a number, just remember you have to figure out the dominant strategy first. So you may have to go to that other option like we did here and then come back to your original option and say, okay, now what should I put in for A? Should it be a larger number or a smaller number? Depending on which option is dominant. So that was your lesson on dominant strategy. The main thing to remember here is that dominant strategy, the one strategy will always work no matter what. And it is possible to have a player that does not have a dominant strategy. And that's okay. We'll come up with different ways to evaluate a game matrix besides dominant strategy. So keep on keeping on.